Hi everyone. Now investigate the datasets, which means that we need to investigate the images and see what's going on inside of these Numpy arrays. So as we have seen on the last video, we actually know that the shape is actually 60,000 to 784, which means that we have 60,000 image, and also each row uh, represents the 28 by 28 image. It is just only X like a string, and we know that it's 28 by 28. 28 multiplied by 28 is 784. Let's show it again. So we have these images, but what are these? So let's say that what is the 15th image, and also what is the label of it? We need to check for it, and we need to understand which image is that. And also with that way we will also validating the labels and the images. To do that, let's say 86th image from the X train, and before going into that, let's see the shape of individual one. Let's see the shape of individual row, and actually we know it, and it's 784, but we know that this is actually only the string, so we need to convert it to some image representation. And to do that, I will be calling the plt.imshow, and I will be getting this image 86th image, and I will reshape it because now it's not in the format of some kind of image, and I need to reshape it to 28 by 28. So now I have the image. I hope we will have no problem on some formats. Let's check. I hope there's no problem. And also I would like to see what is this image, right? So from Y train I again get the 86th image, the label of 86th image, and now when I run this, I hope I will have no problem. Now it's kind of tree, and this guy who writes this tree is kind of mysterious guy. And let's change it to 97, and let's see if it's validating with the original image. So when we run it, it's called 8, and this is also 8, right? So now we are aware of our data set, and let's hide this line, hide this script on here. And now I would like to investigate the dataset. So let's see the first row of it. Let's what's happening. Let's see the first row of X train, and when I run it, as you can see, there are some representations, and it's kind of like between 0 and some value. I actually know that, but let's see that numpy.max and see what is the maximum of this data, and we see that it is 255, and this is not some random value in computer science, and I don't know why the images are represented between 0 and 255, and this is actually a general case, but in terms of channel, there are red, green and blue channels, RGBs, but in this format, in MNIST, it's actually only binary, and it's between 0 and 1, as you can see. Maybe you can understand from here, because it's white and black, so you don't need other channels to represent other let's say colors. And now we know what's going on here, and in machine learning you need to normalize your data for some purposes, but the best format is to balance your data in terms of regularize your data in terms of 0 and 1. So we just would like to put it between 0 and 1, because at the end of the day we would like to predict that what is the probability percentage, let's say, of this image representing 4. So we need to get this right. So if it's 0.4, we will say that it's 40% some class, and if it's too accurate, we will be saying that according to the algorithm it's 95% of this number. But to say this, if we use the images with the image values is between 200 and 255, we need to also diminish this value. So it's actually a general case, and actually you need to investigate it for understanding why we are doing this. In mathematical concept, we are just dividing the maximum value of the dataset to this value, and you are actually normalizing it between 0 and 1. There are some much more better explanations, but I hope this will be enough, and if you don't get it, you can ask it online. And now we are putting our images between 0 and 1, and also let's do it the same for X test. So images of test, and we will be dividing it to this value. Sorry. Now after dividing, actually we also need to check the labels. So what is our labels? As you can see on here, it's actually sorry, it's kind of confusing for now, but I don't know why. Let's say that it's Y test. When we investigate it, we have these kind of numbers. It's 7, 2, 1, and something something, and 4, 4, 5, 6 at the end. So it shows that the first image of the test value is 7, is corresponding to 7. And also we would like to convert it to some format that we would like to present in a probabilistic format. And the reason is, let's say that I have some image and I know that this is, let's say, 4, and I would like to show the probability of the image classification. So when I'm doing this, let's say that I know that this image represents 4, and while I'm testing the algorithm, I would like to see something like this. Probability of being 1 for this image is 0.01, let's say, and probability of being of 2 is 0.05, let's say, and let's say that it goes like that. But 4 is actually or let's say that let's convert it to 3, and this is 0, 1, 2, and for 3 it is generally mixed by the algorithm with 8, because parts are kind of similar when you draw this. 3 and 8 is kind of confusing for algorithm, and I would like to see this. And I know if I know that this image is actually 3, but 3 and 8 is confusing, if my algorithm works very good, I would like to see that the probability of being 3 is, let's say that 1, and I would like to present that this is 1. However, it won't be perfect for logistic regression, and I will see this. It is 0.0. It is 70% 3. This image is 3 with the probability of 70%. And let's say that some other values are going for this, and when it comes to 8, I will see some higher probability at 8, but it will not be larger than 70%, but it will be larger than the others because 8 is somehow uh, understand it as 3, but if you have good algorithm, this value will be high and this value will be low. To represent this probabilistic distribution, and also in a mathematical concept, I cannot do some kind of regression, because let's say that I have some values at here, and let's say that this is 8, and if I would like to directly point out that this image is 3, but if it's confused by 8, so when I do some regression, and if you are aware of regression by linear regression, and if this algorithm is confused by this, and if you just represent your labels in this 2D format or 2 dimension, if it's confused by 3 and 8, your algorithm will say that this is 5, because you have 2D representation, and you should try to directly say that this is 3 and this is 8. And if it's kind of confused, the algorithm will be showing the result of some result that is between 8 and 3, but this is not the thing that I want. I would like to say that if this image is 4, I don't want to see 4, but I would like to see the probability of being of 4. So with that way I can put some threshold for predictions, and let's say that this is 50%. And if this probability is larger than 50%, I will be much more convenient, and I will trust my algorithm, because I will also have the result of probability. To do that, we will be doing one-hot encoding format, and if the image is 1, it will be like 0 and 1. So it means that if the image is 5, there will be 1 at here. If the image is 9, there will be 1 at here, but the rest will be 0. With that way, first I'm going out from the 2D dimensional to escape that problem, and with that way I will have the individual probabilities on each image. So it will be showing that if this image is 5, at this one I will see the probability of 5 with a larger value when it's compared to others, if I have a good algorithm. So to do that, we will be manipulating our Y train, which is in this format, with that way. So let's say that MNIST Y train, and I would like to reshape it for some reason. I would like to reshape the labels, and I don't want to explain it in a long way, because it will take time, and it's just some basic formatting. Y train, and I will be reshaping it to 1, and where is that? Train no, which is 60,000, because we have 60,000 image. So now I have some format. I have this array, label array, with the format of 1 to 60,000. So I'm doing this for some purpose, but it's irrelevant to explain it for now. And now I would like to, my methodology to convert it to one-hot encoding will be this. I will have 0 rows with 60,000 rows, and 60,000 rows will be all zeros. So it will be all 0 element. And if my image is, let's say, 1, or let's say 2, I would like to convert it with that way. If mm, let's first contract the zeros, and the zeros will have the shape of number of images, which is 60,000, and we will have 10 columns, which means that we have 10 digits actually. So with that way, I have full of zeros for 60,000 image, and I would like to do this for the first row. And let's also first print this row, and let's see, 15 minutes too much. And this is my zeros row, and it shows the probability. It will show the probability distribution of the first row. So it's actually the first image. So if it's like this, I'll see the first element of the first row, which means that first row, first column, right? After that, I would like to change it to this. Oh, why it's happening like that? I would like to change the first row of the first element to, let's say 1, because this is my purpose. It is the highest probability. And after that, if I show the first row, I will be seeing that the first element is 1. If I change it to 5, it will be at here. So my methodology will be this. If I can manipulate the row and column like this, I will do this. We have 60,000 image, so I'm using Numpy range, and while doing this I will have actually this will show 0, 1, 2, 3, 4, 5, 6, 7 and 8. Let's also do this. It will show the it's just from 0 to 5999, and we have this for the column, for the rows, and also we have this white train. So it will act like this, and also I will be manipulating this value to 1. Now at first, all this row is consisting of completely zeros, right? So there are a lot of zeros in this arrays. So what I'm doing is, when the arrange value is 0, change the 0 row, and if the first image is 2, for the zeroth row, change the second column as 1. This is the way that I'm creating one-hot encoding. So after doing that, I will be saying that MNIST white train is equal to this, and I will be seeing this one. And when we run it, we will be seeing that I don't like this representation for I in range 10. Show this one. When we print this, we will actually be seeing the values. It means that the first element is 5, first image is 5, and second is 0, the third one is 4, and the fourth one is 2. So that's the way that I create one-hot encoding. And for one-hot encoding, you can investigate the difference between one-hot encoding and this regression approach, direct regression approach. And if you have questions, you can ask on comments. And let's keep going on at the other video. Thank you.